In our last video, we discussed how to use completing the square to find the vertex and axis of symmetry of a quadratic function. In this video, we're going to talk about the formula method to do that. I'm going to take the extra step here of deriving something using completing the square, which we talked about last time, to show you where this formula comes from. So let's go ahead and start off with y equals ax squared plus bx plus c. And I'm going to set this equal to 0 here because I'm going to be interested in that in a second. Let's complete the square on the left-hand side. Factor out a. And that's going to be x squared plus b over ax. We have a plus c on the end here. And now I want to find what it is that's going to complete the square on the inside here. So that's going to be b over 2a squared is going to be b squared over 4a squared. So b squared over 4a squared. If I look at what I just added, I added a times b squared over 4a squared. I added b squared over 4a. So that's what I'm going to subtract out here. Don't forget that I've set this equal to 0. And so this is going to be a times x plus b over 2a squared plus, and then 4ac minus b squared over 4a. There we go. And this is going to be equal to 0. Now, we've completed the square on the left-hand side, so you could probably tell me right now that you see that the vertex of this is going to be at negative b over 2a and at 4ac minus b squared over 4a, like so, for the vertex. And you would be correct in seeing that. So there's a vertex formula that we focus on this part here and say that the x coordinate of the vertex which remember is h to us, is going to be a negative b over 2a. And the y coordinate of our vertex remember that we call that k, is going to be f of negative b over 2a. And we may use synthetic division to help us calculate f of negative b over 2a. We're unlikely to actually do 4ac minus b squared over 4a to calculate it, even though that's what it is. You could figure that out, that that's what it's going to be every time. But let's instead of completing the square every time, look at ax squared plus bx plus c and see if it can give us some information just looking at it as to what the vertex and the axis of symmetry are. Remember that your axis of symmetry is going to be x equals that h value, which is negative b over 2a. And it's an equation, x equals, for your axis of symmetry. All right, let's try some problems here. So number 9 on my worksheet says f of x equals x squared plus 6x. My a is 1, my b is 6, and my c is 0. So my h is going to be equal to negative b over 2a. Be negative 6 over 2 is a negative 3. If I want to find f of negative 3, that's a negative 3 squared plus 6 times a negative 3 is 9 minus 18 is a negative 9. So my vertex is at negative 3, negative 9, and my axis of symmetry is the equation x equals negative 3. Let's try number 10 here. F of x is equal to x squared minus 4x. A is equal to 1, b is equal to a negative 4, and c is equal to 0. So my x coordinate of my vertex is a negative of a negative is a positive. And my y coordinate of my vertex is going to be f of h. It's going to be 2 squared minus 4 times 2 is 4 minus 8 is a negative 4. So my vertex is at 2, negative 4. And my axis of symmetry is at x equals 2. Let's move on to number 11 now. F of x is equal to negative x squared plus 6x. I'm going to skip finding a, b, and c and writing them down. My b is my coefficient in front of my x. My a is my coefficient in front of x squared. So my h is going to be negative 6 over 2 times negative 1. It's going to be a negative 6 over a negative 2 is a positive 3. My k is going to be f of 3. Let's go ahead and let's show you how to do that with synthetic division. If you've forgotten, my coefficients here are negative 1, 6, and 0. Bring down the negative 1 and multiply, and add, and multiply, and add. And so my function value is 9. You can go ahead and try that out by sticking the 3 in there. Negative 9 plus 18 is a positive 9. That gives me a vertex at 3, 9. It gives me an axis of symmetry at x equals 3. That was number 11. Let's try number 12. F of x is equal to a negative x squared minus 10x. So my h is going to be 10 over negative 2 times 2 times negative 1. 10 over negative 2 is a negative 5. Stick the negative 5 on the outside. Negative 1, negative 10, 0. And we get a vertex at negative 5, 25. And we get an axis of symmetry x equals -5. F of x equals 3x squared minus 12x. Negative b over 2a is 12 over 6 is 2. 3, negative 12, 0. My vertex is at 2, negative 12. My axis of symmetry is x equals 2. F of x is equal to x squared plus 4x minus 5. So my x coordinate is going to be negative b over 2a. My y coordinate is going to be calculated this way. My vertex is going to be at -2, -9. And my axis of symmetry is going to be x equals -2. I now have f of x equals negative x squared minus 10x plus 4. Our x coordinate of our vertex is going to be negative b over 2a. Let's use synthetic division. That's at 29. So our vertex is at -5, 29. And our axis of symmetry is that x equals a -5. Moving on to number 16. Our x coordinate is going to be a negative b over 2a. Our y coordinate we're going to calculate using synthetic division. Our vertex is going to be at -1, -5. And our axis of symmetry is x equals -1. Now on to number 17. Our x coordinate of our vertex is going to be a negative b over 2a. So this is a -16 over 4. When I add those together, this is a -39 over 4. Oh, sorry, this is a -41 over 4. My apologies. So my vertex is 5 halves, negative 41 over 4. And our axis of symmetry is x equals to 5 halves. Let's see, I think we've got one more. We do. F of x is equal to a negative 3x squared minus 2x minus 12. So our x coordinate is going to be a negative b over 2a. It's going to give me a negative 1/3. We have a negative 3, negative 2, negative 12. A positive 1. It's going to be positive 1/3. So this is going to be a negative 36 thirds plus 1/3 is a negative 35 thirds. My vertex is going to be at negative 1/3, negative 35 thirds. And my axis of symmetry is going to be x equals negative 1/3. We would not have wanted to complete the square on most of those problems if all we were being asked for is to find the vertex and the axis of symmetry. There was no need to go all the way and write the entire form of the function, but we can use the information that we have, for instance, in this one, to say that we know that a gets written on the outside. This is going to be x minus h plus k. And that should have been the answer that we got from completing the square. So this formula method is going to help you only with parabolas. It is not going to help you with other conic sections in pre-calculus part 2, your analytic geometry, your calculus with analytic geometry. There's going to be things where you need to complete the square later. And this shortcut formula doesn't help you with that. It only helps you with y equals ax squared plus bx plus c and finding the vertex and axis of symmetry of that kind of a parabola. So it's good and efficient, but it's less powerful in mathematics than completing the square. So that's why we did completing the square first. We're going to come back next time and we're going to do some graphing by finding some key points on the graph. We're going to find the vertex, the intercepts, and the axis of symmetry. And we're going to use those things to help us graph some functions. See you for the next video.